Welcome to Unit 4, Lesson 7. This is one of two parts. Today you're going to be learning how to multiply by decimals. And today we're going to be focused on a particular kind of decimal. We're going to be working with only tenths, 1/10, or 1/100ths. That's all we'll be using today. In the past, we've multiplied by powers of 10 and we've recognized patterns. And we learned that when multiplying by 10 or 100 or 1,000, all we simply need to do is move the decimal. And today, while we're multiplying by 1/10 or 1/100th, I want you to try to recognize patterns in our products and see if there are easier ways to do this. So I'd like you to turn to your workbook, page 135. Leon earns $213 a month. The money is shown here. He will save some of it every month. This information here is just showing you what they said up here. This is the $213 that he earns. And it's written correctly. It has a decimal here, and there's nothing after the decimal, and there doesn't need to be anything after the decimal, because if you put the 2 zeros there, it means the same thing. And this is times 1. This is 213 that he earns per month. We're just multiplying it by 1, and 1 times 213 is 213. So there's nothing up here that's not understandable. It's just simply what they said here. Question 1, however, states that if he saves 1/10 of his earnings, this is equal to 1/10, how much will he save each month? Well, because we know that decimals are related to fractions, there's a couple of ways that we could solve this. As soon as I said 1/10, my immediate thought was to write down 1/10. And I said the word of. He saves 1/10 of his earnings. And I know that of means multiply, so I could simply write this as a fraction problem, 1/10 of 213. And this is kind of interesting because if you write it as a fraction problem and solve, you would get 213 on the top and 10 on the bottom, which, as we know from fractions, means that the next step here would be to divide, because we know that this line means to divide. So really what we end up here with is 213 divided by 10. And we've already learned that when we divide by powers of 10, all we need to do is simply move the decimal however many zeros we see. So if we're taking 213 and dividing by 10, we see that we have 1 0. And we also remember that when we divide, we move the decimal on our whole number however many zeros, as many times as we have zeros, in this case 1. But when dividing, we move our decimal to the left however many times we need to. And in this scenario, our decimal, as we also know, is at the very end of the number, so it would be here. And then we would move the decimal 1 time to the left, and it would end up being 21 3/10. And if this is money, it would end up being $21.30. That's immediately would come to my mind when I said 1/10, is that I should be doing this as a fraction. There's nothing wrong with doing that. Fractions and decimals are the same thing. Now, to do it as a decimal multiplication problem, we would take our 213 and multiply it by 1/10. You could put a 0 in front of that if you like. We're going to ignore that 0. Now, if you're looking at this, you should already recognize two things. One, we have a decimal, so that we're going to need to count decimal places. And two, that we're only multiplying by 1. Therefore, if we're taking 213 and ignoring the decimal for now and multiplying by this whole number 1, we realize that our answer should be the exact same, 213. There's no need to do anything with this 0. If we were to do that, we would still end up with 213. So now we look at our decimal places, and we don't forget that we need to look at both of our factors, both 213, which has 0 decimal places, and 1/10, which has 1 decimal place, this one here. A total of 1 decimal place. So now we're going to bring our decimal up. We're going to show it, and it's always going to be at the end. And we're going to move it always to the left, however many times we have decimal places. And that's just 1. So we're going to move it right here. And now you can see that we ended up with the same exact answer as we did earlier with when we converted it to fractions. This is $21, so we need to put a dollar sign and fill out our cents. We're going to need that 0 there because it's representing 30 cents. If it's not there, most people will understand that it's 30 cents, but it's awkward to have a dollar sign and only 1 digit in the tenths place. So we've answered number 1 already, and we can see the answer over here on the bottom of this page. He's saving $21.30 each month. We did that 2 different ways. Question 2, though, asks, what happens to the value of each bill? If you take a look at where these bills are placed now on this place value chart, you'll see that they all moved over 1 digit to the right. That's because we moved the decimal to the left, which pushes all the numbers to the right. The 2 used to be in the hundreds place. That's how much he makes per week, 200. The 1 was here, and the 3 was here. And there wasn't anything here. And so what's happening to each of these digits as they shift 1 place value to the right? And if you recall, I explained this in a previous lesson by showing you this and showing you that if we put a 1 in the ones place, the value of that 1 is 1. And if we put a 1 in the tens place, the value of that 1 is 10. If we put a 1 in the hundreds place, the value of that 1 is 100. And as we move from one place value to another, the value of that 1 increases by 10. It's going up by 10. And the opposite then would be to move from the hundreds place to the tens place, or the tens to the ones place. You can see that they're going down the exact opposite, 10 times less, or we're dividing by 10, but each value is decreasing by 10. That doesn't change as you continue to move this direction across that decimal. They'll still continue to go down by 10. So what's happening to each of these bills is that they are becoming 10 times less than they were before. So the answer is really 10 times less. And if they were moving 2 spots to the right, then they would be becoming 10 times less twice. 10 times plus another 10 times less, which is equal to 100 times less. So if we were to move the decimal 2 times, that would make each of these digits 100 times less valuable. In other words, if I went from the 100, moved the decimal twice, I would be moving my 1 from the hundreds place to the ones place. And the difference between 100 and 1 is 100. So it's becoming 100 times less. It's 10 times less going from one place value to the next, but if you're going 2 place values, it's 100 times less. If you're going to go from 100 to the tenths place, that's 1,000 times less. This would be 10,000 times less, and this would be 100,000 times less. Question number 3 is a bit of a trick question because it's really asking the same thing. What is the value of each digit, and how is that changing? Well, it's changing the same way as the value of each bill changed. It's changing to be 10 times less than it was before. That answer should be exactly the same as number 2. Number 4 says, when you multiply by 1/10, does each digit shift to the right or to the left? Well, this used to be 213, and we moved the decimal to the left, but the digits appear to be shifting to the right. We've done this in the past as well when we were multiplying by powers of 10. And number 5 says, how many places does each digit shift? Well, we only have 1 decimal place in the number 1/10, and we only move the decimal 1 time, so each digit is shifting only 1 time. It's moving 1 time. They're moving from where they started to 1 place value to the right. Remember, the decimal's moving left, which makes the digits appear to be moving right. I'd like you now to complete page 136 on your own. and then complete page 137, number 12 and 13, and then come back for the rest of this lesson. Before completing the rest of page 137, I wanted to show you an example of what you will be doing. So you have a list of factors and mathematical problems to solve here. And we're going to solve the first one. It's simple enough. 12 times 1 is 12. And if you've recognized the pattern and you understand which direction you're shifting decimals and which direction the numbers of the digits are shifting, then you wouldn't have to do any math on this. You could just use mental math, because what we're really going to do here is forget the decimal is there, multiply our whole numbers 12 times 1, because I know that's going to be 12, and then move the decimal to the appropriate number of spaces, and that would mean look at your decimal factor, how many decimal places are in that factor, just 1. So you're going to bring your decimal up on behind the 12 and move it 1 time, which would give you 1 2/10. And we're going to do that again for 12 times 100th. Again, we're going to multiply our 12, our whole numbers, what we see. We're going to ignore the decimal for now and multiply our whole numbers and get 12. And then we're going to focus in on our factor that has the decimal. We're going to count how many decimal places there are, realizing there are no decimal places in 12. That's the only reason why we're not looking at that number, because we want to count the decimal places in both factors. But there are only two decimal places in this one factor. We're going to bring our decimal up and move it 2 times. Always bring up the decimal in the same location and always move it in the same direction. So this would equal 12 hundredths. And even though on the worksheet it doesn't have you multiply by 1,000th, I think we should do that. So we're going to try one here. We're going to do 12 times 1, which gets us 12. We're going to look at the only factor that has a decimal. We ignored that decimal when we multiply, but now we're going to count them. 1, 2, 3. We're going to move our decimal 3 times. 1, 2, 3. Now we have a small issue here where we don't have any digits here, so we're just going to fill it in with a 0 and place our decimal. And our final answer is going to be 12 thousandths. Use this example to complete numbers 14 and 15, and then complete the rest of that page on your own.